Alright guys, in this lesson and some of the coming lessons, we're going to be learning a really crucial aspect of all programming languages, and that is how do you create functions. Now, in order to explain functions, you'll have to imagine that, let's say that I am a little house robot and my name is Angela. I know I told you previously that I'm actually a real human being, but let's just consider for a moment that I'm a robot and I work in your house. And all you have to do in order to command me is to give me instructions in code. So, for example, you could tell me to leave the house using alert leave house. And then you can tell me to take 2 steps to the right by repeating the instruction move right. And then you could say move up 4 steps and move right 2 steps. And this set of instructions takes me to the store. And at the store, you'll ask me to buy you some milk. And then you repeat the instructions to me backwards. And that takes me home, and here is your bottle of milk. Now, if you wanted a bottle of milk every day, you would have to write out all of this code repeatedly every single time you wanted the little house robot to go and buy you some milk. Now, that's kind of tiring, and, at some point your fingers are going to start hurting from writing all of this repeated code, right? So what can you do instead? Well, what if you took this series of instructions that together send the little robot to the store, buys your milk, and brings it back? What if you packaged it into a single package of code and you gave it a name? Well, this is exactly what functions are. They allow you to create a series of instructions, package it into a block of code. And remember, the packaging is done by these curly braces. The opening curly brace specifying where the series of instructions begins, and the closing curly brace specifying where that ends. And everything in between is the block of code that will get executed when you call this function. And you also get to give this function a name. For example, in this case, it's called getMilk. And this is essentially the structure of how you would create this function for getting milk. You first start off with a keyword called function that tells the computer that you are constructing, that you are creating a new function. You give the function a name, you have a set of parentheses or round brackets, and then you have some curly brackets that enclose all of the instructions that you want to be executed. Now, once you have created that function, getting the robot to buy you milk is as simple as calling the function getMilk, and it will carry out all of those instructions that are enclosed in that function, and it will know what it needs to do. That saves you a lot of typing, and that saves you a lot of repetition as well, keeping our code dry, remember? Now, this is the structure of a variable. We use the var keyword to create a new container. The container gets a name, and then finally, we get to put something inside the container. Well, functions work quite similarly. We use the function keyword to say that we're creating a new function, and then we get to give the function a name to identify that block of instructions. And finally, we get to put in all the instructions that we want to be carried out whenever we call the function getMilk. And when we do call the function getMilk, then all of the instructions inside that function will get taken out and executed. Now, the really important thing is to know that there is a difference between when you create the function, because this is when you have the function keyword, this is where you give it a name, and where you have the curly braces that determine what functionality essentially this function is going to perform. But when you want to use the function, in programming we say calling the function. When you call getMilk, then all you have to write is the name of the function, some parentheses, and you end the line with a semicolon. And this is a command. And once you do this, the computer will look to find where this function was created, and it will carry out all the instructions inside the curly braces. If you head over to Chrome and you open up the developer tools, and we're going to go into the sources tab over here, and we're going to write some code in our index.js. Now, I've copied over all of those commands that we had for our little robot, which involves a whole bunch of alerts telling it what to do every step of the way. Now, if you told me, Angela the person, go and get some milk, I already know how to, for example, put on my shoes, how to open the door, how to go outside, and, if I already know where the store is, then I can just go and buy the milk and come back. But with a robot, as with a computer or a browser, it doesn't know anything that you haven't told it to do. So we have to give it detailed step-by-step instructions in order for it to carry out what we want it to do. So in this case, we have a whole bunch of alerts. And if I run this code right now, then you can see that we're going to get a whole bunch of alerts that tells our little robot what to do every step of the way. Now, every single time we want a bottle of milk, we're going to have to write all of this code out. So let's say if we open up a new tab and, it's a new day, we need a new bottle of milk, then we're going to have to write out all of that code all over again. And it's kind of painful, right? So what we learned previously is that we can package this into a function by simply creating it as one. So we can do that by writing the function keyword, and then we give the function a name, so we can call it getMilk. And remember, we're still using camel casing whenever we're naming functions or variables. And all of the rules that apply to naming variables apply to naming functions. So for example, you can't say getMilk. You can't start your function name with a number. So if you can't remember, take a look back at all the rules around how you can name variable names. So now that our function has a name, we're going to give it a set of empty parentheses. And we're going to explain this a little bit later on when we fill out those parentheses. But for now, in our simplest type of function, we're just going to use the keyword function, give it a name, an empty set of parentheses, and finally, we're going to use some curly braces to determine what is going to happen when we call this function. So all the code that's in between these set of curly braces is going to be executed when I call this function getMilk. So that means we want these curly braces to enclose all of our alerts to look like this. Now, in terms of style, when you're creating a function, it's good practice to make all of the instructions that are contained inside the function, and by inside I mean inside the curly braces, to make all of those lines of code indented slightly. So you can tell at a glance these are sort of the children code, and this is the enclosing parent. So the other thing that you'll notice is that your closing curly brace does not end with a closing semicolon. So this is how JavaScript functions should look like. Now let's go ahead and run this code. So in order to execute everything that's inside this function getMilk, all I have to do is write getMilk, some empty parentheses, and finally a semicolon. Now you'll notice I'm not writing the function keyword. I don't have any curly brackets because this is the part where I'm telling the computer to find a function called getMilk and run all of the instructions that are contained inside it. So now if I hit run, then you can see that it's going to execute all of these functions that are inside getMilk. Now, if you don't want to have to keep clicking OK every single time you test your function, then you can change the alert to something called a console log. And we can do that easily by hitting Command F on Mac or Control F on Windows. And this allows you to find the word alert. Now, when you click on this A to B, it allows you to replace it with something else. And we're going to replace it with console.log. And then we're going to hit replace all. And what this does is that it changes all the places where we had alert to console log. Now what this does is that it will log the string that's contained inside here, inside the console. So now if I run this code, which will update our function to use console log, and then it will call the function for it to be all executed, then you'll see that instead of having a bunch of alerts which we have to click through, we get all of those instructions to the robot displayed in the console. Now, the important difference between the console log and the alert is that the alert is something that the user can see. So if you had an alert on your website, then any visitor will be able to see the alert. But the console logs are only for the developer. They only show up in the console, which is not intended for the user. It's meant for the developer to debug your code, to find out if there were any problems, and to essentially print out parts of the code into the console. And we're going to use this more and more as we create more and more complex websites. But you can see that our function is still doing the same thing. It has a set of curly brackets which define what needs to happen. And when we call the function getMilk, then it searches for the function that has the same name and executes everything that's inside the curly braces. Now, as a challenge, I want you to write your own functions, but not inside the Chrome developer tools. I want to introduce you to something called Carol the robot. And Carol is a very simple robot that takes very simple instructions. So let's first change the world to 5 by 5 to make it a little bit smaller and easier to work with. Now, the next thing that you'll notice is that you have this thing called function main. And in this case, everything that you put into here will get executed when you click the run button. And Carol the robot, as you can see here, is able to take a certain number of commands, including move, which moves it forward in the direction it's facing, turn left, put down a beeper, or pick up a beeper. So those are the basic commands that we're going to work with. And let me just demo some of these to you. So if we call the function move on Carol, you can see it moves by a single space. And we can obviously repeat this a few times. So now if we reset and we hit run, Carol will move by 3 spaces because we wrote the move command 3 times. So everything you place into this function main will get called when you hit run, but you can create more than one function. So for example, I know that I can make Carol turn left by simply writing turn left, run, and she turns left. Now, if I wanted her to go around in a circle, then I can simply create a function called go in circle. And inside this function, I can say maybe move 1 step, turn left, then move, then turn left, then move. And now I can go into this function main and I can say go in circle, calling that function that I just created down here, which of course will execute all of the code that's inside the curly braces. So now if I reset and I hit run, you can see that Carol goes in a half circle. So if I want her all the way back to the beginning, then I can simply call this function again, making sure that I've spelt it exactly the same way as I did when I created that function. So now if I reset and hit run, you can see that it turns a full circle. And I can write as many of these as I like in order for Carol to run my code repeatedly. So as a challenge, I want you to write a little bit of code that moves Carol all the way to the right corner on a 5 by 5 world. So inside the resources of this lesson, you'll find a link to the Stanford Carol. So I want you to set the world to 5 by 5, delete what's currently inside function main, and to write some code that gets Carol from the bottom left corner to the top right corner, remembering that you can always take a look at the reference to see what commands Carol is able to use. So pause the video now and give that a go. Alright, so that shouldn't have been too difficult, and there's many ways of solving this challenge, so it doesn't matter which way you used as long as Carol ended up over here when you hit run. So one way of doing this would be getting Carol to go 1, 2, 3, 4 steps forwards, so that would be move 4 times. And then to turn left and then move 4 times again. So now if we hit run, you can see Carol ends up in the top right corner. Now, some of you might have realized that move is repeated here. So you might have created a function that's called maybe move 4 times. And inside this function, you've placed 4 of these move commands. So now, instead of all this repeated code, you can say move 4 times here, and also move 4 times here. So this does exactly the same, as we can see if we reset it, but it's now a little bit shorter and a little bit less repetitive. So using this principle of keeping your code dry, we can use functions to do that. It allows us to remove repetition into these modules of code, which makes our code shorter and allows us to identify problems if it does occur. So for example, if we accidentally written the code wrong and Carol only moved 3 steps each time, then we would know that we can identify the function that's meant to move 4 times and figure out what the problem was. So the next thing I want you to use is the command put beeper. So Carol is able to put down this thing called a beeper, which is kind of just like a square. And I want you to write some code that commands her to put down the beeper in a specific pattern. So the first, slightly easier challenge is, can you get her to put a diagonal line of beepers all the way from the bottom left corner to the top right corner? So that should be 5 beepers in total. And I want you to try and write your code in the least repetitive way possible using functions. So pause the video now and see if you can complete this challenge. Okay, so let's break down the problem. Essentially, Carol will start in the bottom left corner and she can move forwards, turn left, move, put down beeper. So one way of doing this would be writing move forwards, turn left, move forwards, put beeper, turn right, move forwards, turn left, move forwards, and put beeper. So if we run our code as is, you can see that she's begun on her journey, but you might also notice that there's a lot of repeated code in here, especially something like, for example, move, turn left, move, put beeper, move, turn left, move, put beeper. So there's a lot of things that are repeated. So what if we could put all of that into a function? So we can create a function, diagonal move and beeper. Now, of course, you can name your functions whatever it is that makes sense to you. But in this case, I've just called it diagonal move and beeper because I'm going to get it to move diagonally and then put down a beeper. And that involves moving, turning left, moving, putting down beeper, and turning right. So if I take this chunk of code and put it into my function, then instead of calling all of these steps, I can simply say diagonal move and beeper, diagonal move and beeper. And if we do this 4 times, then you can see that Carol will go all the way to the end. And the only one that's missing is the one in the beginning, the put beeper before we do any of these other diagonal moves. So if we hit run now, we've managed to solve our solution by getting Carol to repeat the diagonal move and put down beeper function. Now, you might have solved this challenge in a variety of different ways, and that's fine. As long as you got Carol to perform this functionality, then you have succeeded in completing the challenge. Now, for the final optional challenge, if you want, I'd like you to challenge yourself to see if you can get Carol to create a chessboard pattern like what we have here. So alternating tiles of beepers, essentially. So this is completely optional. It's just a bit of fun and to test your understanding of functions. I will post the code of the solution in the resources section of this lesson so you can check it once you're done trying out the challenge. In the next lesson, I want to talk about a more advanced form of functions. And those are functions that allow you to specify an input. So for all of that and more, I'll see you on the next lesson. Now, in the last lesson, we saw the most basic type of JavaScript functions. And that is a way of allowing us to package a number of instructions into a block of code, which we can execute at once by using the name of the function. Now, if any of that was confusing, then I recommend reviewing the last lesson and playing around with the basic function yourself, either in the Chrome Developer Tools or through using Carol the robot, and just making sure that you fully understand what's going on before you proceed. Now, when I was little, my parents used to love buying these Neapolitan ice creams, which come in 3 flavors, right? Vanilla, strawberry, and chocolate. And I always thought it was really indecisive of them, instead of just picking your favorite flavor, right? But just like ice cream comes in 3 classic flavors, functions also come in 3 classic flavors. And what we saw just now was the vanilla version, the simplest form of the JavaScript function. So let's take a look at the next flavor of functions. And going back to our little house robot scenario, now what if I had the ability to not only say get milk, which executes all of the commands inside the get milk function, but what if I could say get milk, and inside the parentheses, I specify the number of bottles of milk that I want the robot to get? Well, in order to do this, we have to modify our simple function a little bit. And we have to allow it to accept inputs, whereas previously we had nothing between the parentheses because that function didn't take any inputs. In this case, we're putting in the name of the input that is going to go into this function and allows it to be used inside the series of instructions. So in this case, when we call get milk, it's still going to execute all of these alerts to the robot to command it to do something. But in the middle, when we get to the buy milk section, it's going to tell it to buy a specific number of bottles of milk based on the input that the function gets when it gets called. So when we create the function, we're still using the function keyword. We're still giving it the same name called get milk. But in this case, in between the parentheses, we've got the name of the input. And in this case, it's called bottles. Now, that bottles is used much like a variable to contain the input. And we can now use it inside the function to calculate something or to do something with it. In this case, we're calculating the cost. Say if 1 bottle of milk costs $1.5, then depending on the number of bottles of milk the master wanted, then we would have to calculate the amount of money we have to give to the shopkeeper, right? Now, when you call this function, it's similar to what we did previously, but this time, instead of having empty parentheses, we're giving the input of 2. And this will get bound to that name bottles inside the function. So if we call this function using get milk parentheses 2, then 2 goes into bottles. So now we have a variable called bottles that's equal to 2, and then we can calculate cost, which equals to 2 times 1.5, which equals 3. So the cost is $3. And this is the second flavor of functions, which is kind of like the chocolate flavor, right? A little bit better than vanilla. And now when we say get milk 2, our robot knows how many bottles of milk to get. It will also be able to use that number of bottles to calculate how much money it needs to spend at the store and how much change it should get back for its master. So we can use the input inside the block of code. So if we take a look at this inside our Chrome Developer Tools, if we modify our get milk function to take an input, say called bottles, now we're able to use this variable bottles inside the curly braces of this function. So for example, instead of simply console logging buy milk, I can now use that variable bottles inside my code. So now I want the console log to read by the number of bottles plus the string bottles of milk. So now when we call this function, we have to specify an input. So let's say buy 12, right? So let's put 12 in here. Now, once I hit run, you'll see that bottles now takes on the value of 12 and it gets placed inside this console log statement. So now if I hit Command K or Control K on Windows to clear the console, and I run the code inside my snippets, then you'll see that in addition to carrying out all the other commands, it also says buy 12 bottles of milk, and that 12 comes from the input that I used to call this function getMilk. Now, this is a really neat way of modifying your function so that it does more than simply repeating a bunch of code that you've packaged together. So, as a challenge, I want you to change this code here to take money instead of bottles, and I want you to use it to calculate the number of bottles the robot is able to buy. So, for example, if you gave your robot $10 and a bottle of milk costs $1.5, you should be able to modify your function to calculate how many bottles of milk the robot is able to buy based on the amount of money that you gave the robot. So you should be able to say something like, get milk, maybe $5, and if one bottle of milk is, say, $1.5, then that should mean that your robot should be able to buy 5 divided by 1.5, which equals 3.33. So it won't be able to buy a 0.3 bottle. Nobody's going to let it slash a bottle of milk into a third, but it will be able to buy 3 bottles of milk back. So see if you can modify this function in order to take an amount of money as an input and be able to change the console log to state how many bottles of milk it's going to buy based on how much money it got. So if you haven't followed the function up till now, you can download this code here in the resources section of this lesson, and you can use it to complete the challenge. So pause the video now and give it a go. All right, so this time, instead of taking bottles as an input, we're going to take money as the input. And this is just a name that we're going to assign to whatever number comes in through here. So we're going to keep this function call the same. So we're calling the function getMilk, giving the input a value of 5. Now 5 gets bound to this word money, and we can now use it inside the function. So for example, we can say something like var number of bottles equals money divided by 1.5, which we said in this scenario is the cost per bottle of milk. And then we're going to say console.log by number of bottles of milk. But right now, if we clean the console and run our code, you'll see that we're getting 3.3 recurring bottles of milk, which is not what we want, right? We want it to only say 3. So how can we get it to do that? Well, this might have required a little bit of Googling, but essentially what we're trying to do is how do we round down JavaScript? So we can see that the first link that we get is from the W3 schools, and you can see that it's pointing us towards something called the JavaScript floor method, where you can write math.floor, and inside the parentheses, we put the number that we want to round down. So let's give this a go over here. What if we said number of bottles equals math.floor, and then inside these round parentheses, we put in the number that we want to round down. Now, it's important that we're rounding down because even if it was 4.99 bottles, we still can't buy 0.99 bottles of milk, right? So we have to round it down. So now, if we run our code with this floor function here, then you can see that our code now tells the robot to buy 3 bottles of milk, which is exactly what we wanted. So very often when you're trying to do something with code, anything that you're trying to achieve is usually just a quick Google away. So I hope that challenge was interesting. And in the next lesson, we're going to look at an even more complex form of functions, which is functions that can give an output back in addition to taking an input. So for all of that and more, I'll see you on the next lesson. All right, so this was a relatively simple exercise, but I'm going to quickly go through the solution in case you got stuck and you wanted to see how it's done. So The goal is very simple. We want to be able to output this exact sentence, replacing the X, Y, and Z with the actual number of days, weeks, and months we have left if we live until 90. So in this case, our age is going to be passed in as an input to this function life in weeks, and we're going to be able to use it to do all of these calculations. So here it tells us that we're assuming there's 365 days in a year, 52 weeks in a year, and 12 months in a year. So we can use this information to calculate the days, weeks, and months remaining. So let's go ahead and do that. We're saying that we're assuming that we'll live until 90. So let's create a variable called years remaining that's going to be set to 90 minus age. Now, once we've got the years remaining, then we can work out the number of days, weeks, and months left. So days equals years remaining multiplied by 365. Weeks equals years remaining multiplied by 52. And finally, months equals years remaining multiplied by 12. So now that we've got all of our numbers, days, weeks, and months, and make sure that we haven't made any typos anywhere, then we're ready to go ahead and console log the output. So I'm going to go ahead and type out this message, trying to make sure that I don't make any typos and have the same capitalization. So you have X days, Y weeks, and Z months left. Full stop. So this is what I'm going to try and output, and I'm going to replace each of these with the actual calculated values. So I'm going to delete the X, add some double quotes, and then use some plus signs so that I can actually concatenate the actual value of days. And then I'm just going to do this for the other parts. So now that I think I've completed my code, I'm going to click on this link to go to my Replit playground, and I'm going to paste my code inside this function. So now we can go ahead and call this function life in weeks and pass in our actual age. Let's say I am 12, and then we can click on run to see if it actually works. So if I was 12 years old, 90 minus 12 is going to be equal to 78. So the days remaining will be 78 multiplied by 365, which is 28,470. The weeks remaining will be 78 multiplied by 52, which is 4,056. And finally, the months remaining will be 78 multiplied by 12. And that's 936 months. So now that I've assured myself that my function's working, I can go back and go ahead and click on check solution. And hopefully, as long as my sentence matches the exact example output, including all the spaces and the capitalizations and all of the commas and full stops, then my solution should pass and I should have completed this challenge. So how did you get on? If you got stuck, go back to it and try to fix it so that it works. Now, in the last lesson, we looked at the chocolate flavor of functions, which are functions that are able to take an input and use that input inside the function to do some calculation or to use it as a part of the code. Now, in this lesson, I want to show you an even more complex and also more useful type of function, which are functions that are able to give an output. So for example, taking the previous example where we're able to take money as an input to the function and use it to calculate the number of bottles of milk that we can buy, at the end of the code, we can use the keyword return to specify that this function, in addition to be able to take inputs, it can also give an output. And in our case, we're giving the output of money modulo 1.5. So remember that 1.5 is the cost of a bottle of milk. So money modulo 5 means that we're getting the remainder of how much we've spent to buy the milk. So if you remember, the modulo works like this. Whereas 9 divided by 6, 6 only goes into 9 once. So we get a remainder of 3. So in this case, the variable e is equal to 3 because the modulo gives you the remainder of the division. So in this function, if we gave an input of $4 and each bottle of milk costs $1.5, then the robot will buy 2 bottles of milk, which will cost $3, and it'll give us $1 change. And that $1 of change is the output from this function, which we can bind to a variable called change. So for example, we can say variable change is equal to the outcome of the function get milk with an input of 4. And change will equal 1. Because remember, each bottle of milk costs $1.5, so $4 only gets you 2 bottles of milk, which costs $3, and that gives you a remainder of 1. So now the output of this entire function is equal to 1, and that gets assigned as the value to the variable change. That might take a little bit to sit in, but let's just review creating the function in this third type of functions. So the important things are we have the function keyword that specifies we're creating a new function. We have to give the function a name straight afterwards. And then inside the curly braces, we specify whether or not if we have an input that this function is going to use. And in order to get an output out of the function, we have to use that keyword return. And whatever gets returned in the function becomes the right-hand side of this function call. So when we call a function that has an output, we can use the output and we can assign it to a variable. For example, this case, the variable change. So if we didn't have this line where we have a return statement or specify that our function has an output, then calling getMilk only executes the function without getting an output back. So this is the most complex of all 3 functions. And this is the last flavor that we're looking at, which is the strawberry flavor, which incidentally is also the flavor that I never touched because it tastes awful. But our third function doesn't have to be awful, as long as we understand how the return works. So let's take a look at this in practice. So currently we've got our function that takes an input called money, and it uses that input to calculate how many bottles of milk we're able to buy using that money. But at the end of the function, just before we hit the closing brace, we can add a return keyword and specify that we want this function to output a number. And the number is going to be money modulo 1.5, which is the cost of a bottle of milk. So this will give us the remainder of this division. So that means that if we give, say, an input of 3 divided by 1.5 has a remainder of 0, so we'll end up returning 0. But if we gave it a value of 4, then we will have a remainder of 1. And that number 1 becomes the output of this function call. So we can capture it and save it inside a variable called change, for example. And I can log the value of change by writing console log brackets change. So now if I hit run, you can see that all of those lines of code get executed and it shows me that I'm buying 2 bottles of milk, but it also shows me that I'm getting a change of 1. And that comes from this return statement. So this is quite useful because it allows us to use a number of functions inside other functions. So for example, if instead of messing up my bunch of instructions, I took this part where I calculate the number of bottles of milk I get based on money into its own function. So for example, let's create a function called calc bottles, and it takes an input in the form of starting money and also cost per bottle. So we can now say that the number of bottles is equal to this input called starting money divided by the cost per bottle. Right? This is always going to be the same calculation that you need to perform, no matter which scenario. So you could have a starting money amount of $5, $10, $20. It doesn't matter. And if you divide that by the cost per bottle of milk, then you will end up with the number of bottles. So now, how can we use this function inside here? Well, if we give this function a return statement and we say that the output of this function is the number of bottles, then up here we can write console.log by plus calculate bottles using the amount of money we got as an input over here as the first parameter, which is starting money, and the second input, 1.5, as the second parameter, which is the cost per bottle. And now, once our code gets to this line, which is line number 12, then it'll go and find where this function was created, calculate bottles, which is down here, of course. It will place the value of money into starting money, 1.5 into cost per bottle, and it will calculate the number of bottles. And once it gets to this return statement, that value in number of bottles will replace this part of the code because it is the output of the function. So now if I call my first function getMilk and I specify an input of say $5, then that $5 is going to go into this parameter called money, and then it's going to move over here in order to use it to calculate the number of bottles we'll get back. So if I hit run, you'll see that all of the instructions are executed, and it also tells me that I'm able to buy 3 bottles of milk and have 0.5 as the change. Now, what if we did the same thing down here? What if instead of doing the calculation in here, we created another function and we called this function calc change? And the inputs that it's going to take is starting amount and also the cost per bottle. And inside this function, I'm going to calculate change, which is going to be equal to starting amount modulo cost per bottle. And that is what I'm going to return as the output of this function. So now, instead of returning this calculation, I can simply return calc change, and the first input is going to be money, and the second input, cost per bottle, is going to be 1.5. And that becomes the output of this function, which is getMilk. So instead of just calling getMilk here, I can also say console.log, call this function getMilk, and we're going to add it to a string. So we're going to say, hello master, here is your whichever amount that you get plus change. So now if I run the code, you can see that it goes through all of the commands, buys 3 bottles of milk, and finally we get, hello master, here is your $0.5 of change. So as you can see, what we're doing here is we're using the outputs of functions in order to use it inside other lines of code. So now, say if the cost per bottle of milk changed, right? Say it now costs, I don't know, $2.5 instead of 1.5. Then we don't actually have to change the calculation. And in fact, we can make this even more dry by reducing the repetition inside the function. So as an input, we can say getMilk, the amount of money as an input, and also the cost per bottle as an input. And we can replace that here. So now, when we call getMilk, we have to say the amount of money we got given is 5, and the cost per bottle is, say, 1.5. So this will give us 3 bottles of milk and 0.5 change. But say tomorrow the master gives us $10 to buy milk, and the cost of milk has gone up to $3. And now we're able to only buy 3 bottles of milk, but we get $1 change. You will find yourself using all 3 types of functions in a variety of scenarios, depending on what it is that you're trying to do. There's a lot of new information that you've learned, so it's really, really crucial that you try to understand this information by completing some exercises and trying to write the code yourself. So in the next lesson, I have an interactive challenge for you, where I want you to write some code, and we will use some software on our side to test your code and see if you got it right. So for all of that and more exciting stuff, I'll see you on the next lesson. All right, so in the next lesson, you're going to tackle the interactive challenge where you have to write the code and I will check your solutions behind the scenes. So this is what you should see. This is the BMI calculator challenge, and there's a little bit of a description about what BMIs are and what they're used for. Now, the most important thing is that I've included the formula to calculate the BMI, which is the weight divided by the height squared. And this is weight in kilograms and height in meters. So your challenge is to create a function that takes the weight and the height as inputs, like so, and to be able to give the output, which is going to be equal to the BMI. So that if I run this line of code using the function that you create, which is going to be called BMI calculator, I should be able to get the BMI inside this variable called BMI. Now, the order of your inputs matter in this case. You're going to have to put the weight as an input first and then the height as an input in order to satisfy this line of code. So you can copy what's inside the index.js file in here, and you can paste it into the snippets tool here to write your code and to test your code inside the Chrome Developer Tools and use the console. So if you're here, you can activate this line of code and try to write your function here so that when you console log your BMI variable, you should be getting the same value back as any BMI calculator online. Now, once you're happy with your function, then you can go ahead and click Check Solution in order to check to see if you got it right. And once you're done, then you can go ahead and continue on to the next lesson, where I'll go through the solution with you step by step. All right, so we know that the formula is weight in kilograms divided by height squared, and we have to make this line of code work. So let's first try it out in the calculator. Let's say that we first try to square our height, which is 1.8 meters. So on a calculator, we could simply write 1.8 times 1.8. So 1.8 squared is equal to 3.24. So now we can divide 65 by 3.24. 65 divided by 3.24 and we get 20.0617 something something something. All right, so now that we know that this is how we would calculate it on a calculator, then we can simply copy all of this starting code and open up our Chrome Developer Tools and paste it into our snippets tool. So now we're going to create our function below this line, and the first step to creating any sort of function is the function keyword, right? Then we're going to give our function a name, which we said has to be the name BMI calculator. So we're going to use that name. Next step is some parentheses and whether if we're going to add some inputs in here. So in this case, we're saying that put the input weight first and then put the input height. So our inputs are going to be weight and height. Now we get to open up our curly braces and specify everything that this function is going to do. So this function has to calculate the value of BMI. And remember that the formula is the weight divided by height squared. So BMI is going to equal to the weight input divided by the height input multiplied by itself. And remember, in the previous lesson, we talked about JavaScript numbers, that in order to specify the order of your calculations, then you can use the parentheses to set precedence. So by putting those two parentheses there, then we say that calculate height times height first, and then divide weight by that value. So now, in order to get our value BMI out of this function, we have to use the return keyword, and we can say return BMI. So now if we take all of this code and we go back to our exercise here, we paste it in here, and now if I hit check solution, then you can see that it will pass. Now there's a number of different ways of writing this function. Some of you might have wondered, I don't really want to multiply the height by height in order to get it squared. Why can't I just raise height to the power of 2? How would I do that in JavaScript? Well, as with any query regarding programming, the solution is only a quick Google away. So if we search for raise a number to a power and we add the keyword JavaScript, then you can see that the MDN docs come up with the math.pow function. and it shows us how to use it. It says that we can simply say math.pow, and the first number is the base, and the second number is the exponent. So this is your squared, which will be 2, or cubed, which will be 3. And this is how you would use it. So let's try it out in our case. Instead of writing height times height, what if we did math.pow, set of parentheses, and then we said height, comma, 2. So height to the power of 2. Now, if we check our solution, you can see that our function is still working exactly as we expect it to, but it's now perhaps a little bit more elegant. Now, if you run this code as it is right now, for example, we're calculating the BMI from 65 kilograms and 1.8, and then we're logging that BMI into the console, then you can see that we're getting a really long number, 20.0672H39, etc. Now, usually with BMIs, we're working with whole numbers. So how can we turn this long number with loads of decimal places to simply a whole number? Well, again, Google is your friend. And if you search for JavaScript, round a number to the nearest whole number or something around there, then the first result that you get is from W3 Schools. And it tells you about the round method, which you can use by saying math.round. And similar to the floor method, which simply rounded down your decimal place, but math.round is more mathematically correct. So if it's 2.5, it will round it to 3, and if it's 2.4, it'll round it to 2. So let's try using this in our solution. So if instead of returning BMI, we returned math.round, and inside the parentheses, we enclosed our BMI as a number with decimal places. Now, if we run our code, you can see that we only get 20 back, which is exactly what we wanted. And if you change our solution to this updated one inside our testing suite, then you can see that our solution also passes. So I hope that was interesting, and we've got a few more of these challenges coming up for you. So keep your eyes peeled. But in the next lesson, we're going to dive deeper into JavaScript, and we're going to learn all about control flow. So you have all of that and more to look forward to. So I'll see you on the next module.
Now, one of the things you often hear from people is, oh, programming is easy. Everybody can do it. If you're an 8-year-old, if you're a 60-year-old, everybody can learn to code, and it's super easy. And sort of my response to that is that it's really, really irresponsible for people to say this, because quite honestly, programming is hard. Like, don't fool yourself, and don't listen to the people who say like, oh yeah, it's totally easy. Yeah, maybe like the first part, like, when you just create like a variable and you add 2 to it. Yeah, that's easy, but it's hard. Like, actually being able to master code, it's not easy. It's definitely not easy. And, you can't think like, oh, why is it that everybody's saying it's so easy, but like I'm finding it so hard? Does that mean that I'm dumb? Like, it's not true. It's a hard thing that you're doing. And just by getting this far, you've already shown like what you're made of. And you've already learned so much. But, the other sort of side where people flip to as well is like, programming is impossible. Like, you either have to be like a genius or you're not going to get it. And that's not true either, because, very often, like, I look at, people, students who say, like, oh, like, you're so great, like, I can't be like you, but, like, there is nothing that anybody has on you. Like, if you go on YouTube and you look at all the developers who talk about, like, a day in the life of a developer, or I am a developer. Like, if you look at those people or me, like, there is no difference between these developers or these people who've learned it and you. Like, nobody is better than anybody. It's just the amount of work that somebody has put in. If you put in more work, you end up with more results. That's all it is. So what I want to say is that don't be fooled by these two things that people say. Programming is easy, or programming is really, really hard and impossible. They're both not true. Programming is hard, but it's doable. And it's doable by you. as long as you keep going like you have been, then you're going to get there. And I believe in you. So keep going and you're going to do great.